Factors and products, lesson 3, common factors. So just as a reminder of what a factor is, an example would be a factor of 9, or factors of 9 are 1, 3, and 9. Because 1 times 9 is 9, and 3 times 3 is also 9. We can factor 9 into the prime factorization 3 times 3 or 3 squared. So similarly, we can do this with variables too. So the factors of x squared are x times x. You're noticing that I'm using a dot for multiplication. I'll try to be consistent with that, or brackets. And since x represents any number, therefore, or x represents any number, therefore x squared is a perfect square because it's the same number multiplied by itself. The factors of y to the power of 3 are y times y times y. Okay, so this right here should be kind of a review from grade 9 a bit. So a variable represents a number. This is a letter. We use x a lot. A term is an expression using numbers and or variables, and a polynomial is an expression with a number of terms separated by addition and subtraction. So a monomial is a single term polynomial such as 3x or something like 4x squared y or negative 7x squared, or simply just the number 8. That's also a monomial. A binomial is a two-term polynomial. So an example of that would be 2x plus 4, or something crazy like 6y squared minus 3ab. Oh, the bracket went on to the next line. That's funny. So a trinomial is a three-term polynomial. So an example of this would be something like 6x squared minus 2x plus 7. If we write a polynomial as a product, so multiplying two things together, so a product of factors, then we have factored the polynomial. Today is all about factoring. To complete the factor, we wish to pull out or divide out. I kind of like that language a little bit better. The greatest common factor. When we do this, we're just really dividing by the greatest common factor. So think lowest terms with fractions, okay? So if I were to say, something like 6 over 8, the greatest common factor between these two things is going to be 2. So what I can do is I can say 3 times 2, and I can say 4 times 2, and I can cancel out the 2 and the 2, and I'm left with 3 over 4. We're essentially doing this exact same thing, except with polynomials instead of fractions. So remember to take little steps, like what are the common number factors? And then what are the common variable factors? Sorry, I'm gonna rewrite this elsewhere. It just kind of shifted kind of funny, but I want to use that space. Okay, so for example, what's the greatest common factor between 20 and 16. Well, 5 doesn't go into both. 2 goes into both, but there's a bigger number that goes into both. So 20 is 4 times 5, and 16 is 4 times 4. So the greatest common factor between 20 and 16 is 4. What about the greatest common factor between 14x squared and 6x? So this is where it gets a little bit more tricky. So the greatest number factor is going to be 2, because 2 goes into 14 and 2 goes into 6, but there are no other common factors. So the numbery bit is definitely going to be 2. But in terms of the lettery bit, the greatest common factor, I have x times x here and just x here. So the greatest thing that's common between them with the lettery bits, with the variables, is x. So the greatest common factor between 14x squared and 6x is 2x. Okay, I am going to rewrite this one. You do not need to though, okay? So for our first example, we're going to factor 4m plus 12. So first method I'm going to show you with algebra tiles. So when I look at my algebra tiles, this guy right here, oh, I don't want that. This guy right here represents an x squared. But what we want to represent right now is 4m plus 12. So I'm going to take my m, 1m, 2m, 3m, 4m, and then I'm going to have 12 ones. So I'm going to say 1. I'm going to kind of do it as an array. 2, 3. Oh, where are you, little buddy? There we go. There we go. 1, 2, 3, 4. I'm going to grab these guys here and I'm going to say copy. 1, 2, 3, 4, 5, 6, 7, 8. 9, 10, 11, 12. Oh yeah, no, that's good. I don't need to go more than that. I was going to go all the way up to 16. I just need 12. So what I am doing here is I have 4 x's, okay, 4 x's, and I have 12 ones. But in a way, what I have is one group of x plus 3, another group of x plus 3, another group of x plus 3, and another group of x plus 3. I'm trying to see if there are any things that are common between them, and I'm noticing that I have literally 4 groups of x plus 3. So when we factor it, it's asking how many groups of variables do we have? Well, the answer to this one just visually is 4 groups of x plus 3. So I know that I have 4 groups of x plus 3. But what does this look like algebraically? Okay, so we know that this is the factored answer. We know what it is. But let's try to get there without algebra tiles. Though if you need to use algebra tiles, we can definitely let you use algebra tiles, especially when we're first learning how to use factors. Okay, so first things first, let's find out the greatest number factor. So our greatest number factor between 4 and 12 is going to be 4, because 4 times 1 is 4, and 3 times 4 is 12. So our greatest number factor here is going to be 4. 4 goes into both terms. And what's the greatest common letter factor? The greatest common letter factor, there is none. Because in one of the terms we have an m, and there's no variable in the other one, so there's no greatest common letter factor. So I would say if I were to look for m plus 12, that means 4, and then I go 4 divided by 4m, and what I'm left with is simply m. Saying 4 divided by 4m, my bad. 4m divided by 4. That's just simply going to be m. And then the next thing that I need to worry about is 12 divided by 4. So then I'm left with 3. So visually, I got to 4 groups of m plus 3. Algebraically, I got to 4 groups of m plus 3 as well. We can always check our answers to see if we got it right. I mean, like, you can check in the back of the textbook, but we can check by distributing the 4. So let's check. I'm going to say 4 times m plus 3. And remember, when we use the distributive factor, which you used last year, so you've come across it. Maybe you forget it, but we'll shake the rest off a little bit. So 4 times m is going to be 4m. 4 times 3 is going to be 12. That means that we get exactly the same as our question, which is exactly what we want to do. An important thing to m plus, yeah, this brings me to a really good point. So that little mistake right there, your answer should have the same number of terms as the question. Okay, so I'm seeing here 4 is multiplied by an m and a 3, so that's 2 terms. And in my original question, I have 1 term and 2 terms. So make sure, because sometimes, like the mistake that I made there, I forgot to put the plus. But then that means something totally different. 4m 12 means 4m times 12. That's not what we mean at all. Okay, let's try this one. Okay, so this one right here, greatest common number factor. Okay, between 4c, between 4 and 6 is going to be 2, because 6 is 2 times 3 and 4 is 2 times 2. So the greatest common factor between these is going to be, is going to be 2. My bad. It's going to be 2. Okay, so then the greatest common letter factor. So I have a 6c and a 6c squared. So what's common to both of them is c. Not c squared, because this one doesn't have a c squared. But what's common to both of them is that c. So what we're going to factor out is 2 times c. So if I have 6c plus 4c squared, that's the same thing as my greatest common number and letter factor combined is 2c. Now what I'm going to do is I'm going to say 6c divided by 2c is simply going to be 3. Okay, and 4c squared divided by 2c, so there's a plus here, so we can't forget that. Plus, so 4 divided by 2 is going to be 2. C squared divided by c is going to be c. So then what I'm left with here, factored form, is 2c times 3 plus 2c. We can always check. Okay, so I'm going to say 2c open bracket 3 plus 2c. So I'm going to use my distributive law. 2c times 3 is going to be 6c. 2 times 2 is 4. Oh, don't forget the plus. 2 times 2 is 4. C times c is c squared. Perfect. It's the same as the answer, so we're good. Okay, so you're going to see trinomials actually quite a bit. Okay, you're going to see trinomials quite a bit here. So you don't have to do this step. This step right here will just come naturally the more that you do. But if you find that step very helpful, keep on doing it. I'm going to keep on doing it for the video. But honestly, like I'm just going to do the quick version. When I look at this one right here, when I look at that question right here, I'm noticing that the greatest common factor between 5, negative 10z and negative 10z squared is simply going to be 5. Because we don't have a z on this one. Oh. we don't have a variable on this one. We don't have a z on this one. So the greatest common factor really is just going to be a number. So, I mean, I can very quickly say, okay, I'm going to divide out a 5 from each of the terms. 1 minus 2z minus z squared. Okay, so that is the goal. Okay, that is the goal in speed. But let's not go that fast when you're just learning. Okay, so first things first, what's the greatest common number factor? So the greatest common number factor between 5, negative 10, and negative 5 is going to be 5. So I can factor out a 5 from all of them. The greatest common variable factor or letter factor is going to be none. There are none, because this guy right here has absolutely no variable. So we can't divide out a variable. Okay? So I'm going to say 5 minus 10z minus 5z squared is the same thing as I'm going to factor out my 5. If I had a z here, then I would say 5z, but I don't. Okay? So I'm going to say 5 times 5 divided by 5 is 1. Negative 10z divided by 5 is negative 2z. And negative 5z squared divided by 5 is negative z squared. Just like that. And again, we can check. We're going to use our answer here, 1 minus 2z minus z squared. We're going to use that distributive law, but to 3 this time, okay? So 5 times 1 is 5. 5 times negative 2 is negative 10z. 5 times negative z squared is going to be negative 5z squared. Perfect. Okay, so this one, it should be better on your page. But what I'm going to do is I'm just going to leave it here and kind of go between both of those pages. So this is a bit of a tricky one. So first things first, let's just write out each of the terms' factors. I'm going to take a little bit of a different approach, but it's still, I think that it's still pretty decent. Okay, so I'm going to say negative 12 x squared y. If I write out all the factors, I'm going to say negative 3 times 4. Oh, I don't want to use x. 3 times 4, but 4 is the same thing as 2 times 2 times x squared. So x times y. Okay, and I'm going to go back and I'm going to highlight all the things that are common. Okay, so then I'm left with also negative 20 x y squared. So I'm left negative 5 times 4, but that's negative 5 times 2 times 2 times x times y times y. Okay, let's do the last thing with the 16. Negative 16 x squared y squared is the same thing as negative 8 times 2, which is, or 4 times 4, which is just the product of 4 2's all together, times x times y times y. Okay, so let's see what's common. I'm just going to use my highlighter function here. So I'm noticing that each one has a 2 times 2. So I'm going to highlight that. This one has an x squared. I'm just going to do, this one has an x squared, but this one only has an x. So what's common isn't going to be x squared. It's just going to be one of the x's. And then last but not least, I have y squared, and y squared. So that the common thing that's between all three terms is going to be just simply y. So I'm going to say the greatest common factor between all of them is going to be 2 times 2, which is 4, x, y. So we're going to divide each of the terms by 4xy, and I'm just gonna relate the colors here. Okay, 2 times 2 is 4. Then we have the oh, that's not very clear. There we go. We have the x, and then we have the y. Okay, so now what I'm gonna do is I'm gonna say, okay, negative 12x. Oh, sorry, I made a mistake here. This should be x to the power of 3, not x squared. Sorry about that, my friends. But it doesn't actually change anything, but it would change the answer some. So I'm going to just squish in another little x here. Sorry if you caught that and your brain is on fire right now. Let me just make sure. Okay, I didn't make any other mistakes there. Okay. Okay. Negative 12x to the power of 3y minus 20x squared y squared. No, not x squared y squared. xy squared minus 16 x squared y squared. There we go. Okay, so now I'm gonna have here out in front, I'm gonna factor out the greatest common factor with the lettery bits and the numbery bits, okay, which is 4xy. So when I go into, and really what I could actually do is I could carry that negative as well. So if I wanted to, I could factor out the greatest common factor is actually with that negative out in front too. So we're going to do that, because then my answer in the brackets is going to be positive, which feels nice on my brain personally. Okay, so if I go negative 12 divided by negative 4. So if we just deal with the little bits by little bits, negative 12 divided by negative 4, that is simply positive 3. Then we have x to the power of 3 divided by x, which is just going to be x to the power of 2. Y divided by y. There's no y anymore. Woohoo! Because y divided by y is 1. All right. So then I'm going to go negative 20 divided by negative 4 is going to be positive 5. Okay. And then I have x divided by x, which is simply 1. So the x just turns into multiplying 5 by 1, which is just itself. And then we have y squared divided by y, which is just simply going to be y. And now, last but not least, negative 16 divided by negative 4 is going to be positive 4. And then I have x squared divided by x, which is just going to be x. And then y squared divided by y, which is just simply going to be y. Okay, so that was a spicy meatball, but remember, we can always check by using the distributive law. So negative 4xy, open bracket 3x squared, plus 5y, plus 4xy. I'm going to distribute this all the way through, and I should get the same as my answers. Okay, so negative 4x times 3 is negative 12. X times x squared is x to the power of 3. And then I just have a y, because there's no y to multiply by here. Then I'm going to go negative 4 times positive 5, which is negative 20. X times 1 is x, and then y times y is going to be y squared. Last but not least, negative 4 times positive 4 is going to be negative 16. X times x is x squared. Y times y is y squared. And look at that. We have our answer again. Or sorry, we have our question again, which is awesome. This might feel really big and overwhelming, and for a few reasons. Sometimes we come into this course with multiplication tables. Okay, so something that will really strengthen the skill is memorizing multiplication table. just so that we're like really in tune with what factors are. Another thing is getting fluent with division facts. Sometimes we're really good at multiplication, but the backwards is a little bit more difficult. So fluent with division facts. Okay, so these two things right here make it difficult if you don't have it right at the tip of your right at the tip of your brain. So please, 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 if you are finding yourself in this boat right here, it is worth investing in memorizing. I have lots of like digital resources that can help you, even 5 minutes a day, just get way better at all of these different things. So please come and talk to me if you find yourself in this boat. And also, if you need to use algebra tiles, we can definitely find that. We can do digital version, or if you like more hands-on stuff, we can get you like hands-on copies of them, no problem. Okay, so question number 4 you use if you're using algebra tiles. Otherwise, you can just work on here. And again, doing tons of these questions is the only way that we're gonna get better at them. So sink your teeth into this one. It's a big concept, but you can do it.